Okay, so by this point in class, we've already discussed that the derivative of sine is cosine, the derivative of cosine is negative sine, the derivative of tangent is secant squared, etc. So I have these here for your reference, but what I really want to practice is, coupling the fact that, we know these derivatives along with the product rule, the quotient rule, and other derivatives that we've done in the past. So let's just take a look at one lovely all-encompassing problem here. I'll zoom in on that. So again, I'm always picking problems from the book and from the online work that we can work through together. I'll rewrite it for starters. It says y equals 4 over cos x, cosine of x, plus 3 over tangent x. So that's what's given here. We're asked to find dy dx. So find the first derivative, find y prime basically. Now, it's multiple choice, and obviously I've already input the right answers here, so it's just a matter of how are we going to get to that answer. So let's work through that together. So let's go ahead and use the quotient rule on this part right here. So bottom function times the derivative of the top, but the derivative of 4 is 0, right? Minus top function times the derivative of the bottom. Well, the derivative of cosine is negative sine. Okay? All over bottom squared. So just this component right here, okay? And I'm kind of running out of room there, so I'm going to scoot that down. Now I'm going to clean that up. So 0 times anything is 0. Negative times a negative is a positive. So at that moment, we're arriving at y prime is equal to 4 sine x over, you could say cos x whole thing squared, or you could just say cos squared x. You could say it like that. But now, notice all of that sweat equity was just for this first part. Now we have to do a quotient rule on this part here. Okay, so let's talk through that. So bottom function, which is tan x, times the derivative of the top, well, the derivative of 3 is 0, minus top function, times the derivative of the bottom, well, the derivative of tan is secant squared, all over bottom squared, which so you could say tan squared x. So, when you arrive here, I always tell the students in my live class, when you arrive here, this makes me happy, and it's right. It's just not cleaned up. You just got to keep cleaning, right? So if you see the author's final answer, you say, how in the world did they get it to that point, right? So they're constantly manipulating, using trig identities, etc. All right, so tan x times 0, this part goes to 0. So at that moment, and it's probably, good that we practice together in terms of, gee, how do you clean up this lovely expression? So cos squared x plus, and here we have negative 3 secant squared x all over tan squared x. So what you do, I'm going to scoot this on down. What you do is you kind of zoom in on this piece here. Secant squared over tan squared. I'm just going to kind of think about that. Secant squared really means 1 over cos squared x. And tangent squared really means sine squared x over cos squared x. So if you see that whole quantity here could be manipulated, seen as a complex fraction and manipulated. So, in fact, I'll do that in another color. I always, when you have a complex fraction like that, then you can do the outer product over the inner product. So you're basically going to arrive at negative 3 and then the outer product, cos squared x, over the inner product, which is cos squared x, sine squared x. Aha, but those cancel. So after all that sweat equity, you arrive at -3 over sine squared x. Now bear in mind, 1 over sine is secant. Excuse me, cosecant. So, I'm scooting back to the final answer here. Notice the final answer it has -3 cosecant squared x in it. So let's just keep cleaning on that though. Let's look at this part here as well. Bear in mind that 4 sine x over cos squared x could be rewritten as cos squared x means the same thing as cos x times cos x, right? But check this out. Sine x over cos x means the same thing as tan x. All right, so in this next step, a lot of this is just like manipulation, right? So in this next step, I'm going to rewrite this. The sine over cos, I'm going to rewrite that as tan. So I'd have 4 tan x over cos x. Okay? So keep that in mind. Let me scoot that on down to where we were before. So at that moment, I have 4 tan x over cos x plus -3 over sine squared x. Now you could see, hopefully you can see how that's going to translate. The cosine x being in the denominator here, let me scoot that down a little bit more too. Oops. Here, the cosine x being in the denominator here, like I said, 1 over cos is really secant. So after all that, I'm going to arrive at 4 secant x tangent x, and then this lovely expression here, like a sine squared being downstairs in the denominator, really means that's going to translate to, plus -3 cosecant squared x. So you have to translate a little bit to morph it into that final form of where the author has it. And let me go back to that. See? So the final form where the author has it, and I'll even zoom in. See that? They arrive at 4 secant x tangent x minus -3 cosecant squared x. And the zoom on this is being really fussy, but we eventually arrive at that same spot ourselves. 4 secant tangent x minus 3 cosecant squared x. Okay? So all of this will turn into that. All right, so a lot of that has to do with your strength in trigonometric identities. I hope that helps. And again, I do want to remind you that, let me take away part of this here. I do want to remind you that, if you arrive here, like I said, you're right. It's just all of this manipulation that you have to do to get it to this final form right here. Okay? All right, hope that helps. Keep practicing.